This video is covering page 2 of the Chapter 1 test review, so 5, 6, 7, and 8. And number 5, we're going to use this diagram to decide whether the statement is true or false. So points A, R, and B are collinear. Is that true or false? A, R, and B are those points that I highlighted in orange. In order to be collinear, they would all have to lie on the same line. They do not. So this statement is false. B, line BW and line AT are lines. If I look in this diagram, here's line BW and here is line AT. Those are both lines in the picture. That is true. Ray BR, let me use a color here. Ray BR, that would be the ray starting at endpoint B and pointing towards point R. And ray RT, that would be a ray starting at R and pointing towards T, are opposite rays. Remember, opposite rays share an endpoint and point in opposite directions. The blue and red ray do not start at the same endpoint and do not point in opposite directions, so this is false. Plane D could also be named plane ART. Plane ART, these are all points that are on plane D, but remember, if we're going to use points to name a plane, they cannot lie on a line. So A, R, and T, these are 3 points that all lie on the same line, so we couldn't use these 3 points together to name the plane. We could use, for example, ARB or ATW. We just cannot use these 3, so that is false. And number 6, we need to find the perimeter and area of the polygon with the given vertices. Round to the nearest tenth if necessary. Let's go ahead and first plot these points on our graph. If I do this too fast, you can always pause the video and then catch up. Sorry, this is not perfectly. All right, so we have a triangle here. Let's go ahead and first find the perimeter. Remember, perimeter is the distance all the way around the figure. So I need to find the length of each side of the triangle and add them together. The good news is I can count the length of JK because this is horizontal. This has a length of 6. But now JL and KL, these are sides that are diagonal on my graph. So I need to use the distance formula to find these lengths. So the distance formula is provided to you. I'm going to rewrite it here. And I'll find the length of JL. And what you'll end up noticing is that the length of JL will be the same as the length of KL when you go and use the distance formula. So we're just going to find the length of JL to keep the video short. So since I'm finding the length of JL, I need to label point J and L with x1, y1, x2, y2. Make sure you're using the correct coordinates for finding your lengths. So I'm going to plug these numbers in. X2 is 2, minus x1 is negative 1, y2 is negative 2, minus y1, which is 3. I see minus a negative, so I'm going to go ahead and turn that into a plus. 2 plus 1 is 3. Negative 2 minus 3 is negative 5. when I square these numbers, 3 squared is 9, and negative 5 squared is 25. And when I add these together, I find that I have to take the square root of 34, and I'm going to round to the nearest tenth. So when I take the square root of 34 on my calculator, I get approximately 5.8. So this length here is 5.8. And remember I said this is also going to be 5.8. So to find the perimeter, remember we have to add up all three sides. So the perimeter is 6 plus 5.8 plus 5.8, which gets me a total of 17.6. I now need to find the area of this triangle. So I need to use the area formula for a triangle. So I need 1/2 times the base times the height. I've already found the length of the base. That was 6. I'll label it B. And remember, the height of my triangle is when I locate my base and I find the vertex opposite the base, and it's that straight line segment that makes a 90-degree angle with the base. So this is my height, which I can count because it's a vertical line. Let's see, 1, 2, 3, 4, 5. So I'm going to take 6 and 5 and plug them into my area formula. 1/2 times 6 times 5 gives me an area of 15 square units. Number 7, I went ahead and drew a diagram here. So it says a man is 76 inches tall. So here's my man. And then next to him, I drew a line segment to try to represent the different parts of his body. So point H represents his head. Point S represents his shoulders. Point W represents his waist. And I kind of messed up and I first drew his waist, not very good. And then point F represents his feet. So we can kind of use this as a reference when they give us different lengths. The length from his head to his shoulders, so the length from his head to his shoulders is 14 inches. The length from his waist to his shoulders is 30 inches. What is the length from his feet to his waist? So keep in mind, we also know this total length is 76 inches. So this is one of those problems where we need to use the segment addition postulate. We know that the pieces or the parts must add up to equal the whole. So if I take the whole, I can subtract the pieces I know to find my missing length. So if I take his total height and I subtract 14 inches, the length from his head to his shoulders, and I subtract 30, the length from his waist to his shoulders, that should give me the length from his feet to his waist, which is 32 inches. So sometimes when you have problems that are wordy like this, it helps to draw a picture. And number 8, circle the figure below that contains a plane, so a plane, one plane, and 2 lines that intersect or cross the plane at one point. So we're looking for 2 lines that cross on the plane. In this picture, I have my 2 lines intersecting, but where they intersect, that point is not on the plane, so that's not going to work. This picture doesn't even have 2 lines, so that doesn't work. And in this picture, my 2 lines don't intersect at all. So this is the picture where we have 2 lines intersecting the plane at one point.